Hi everyone, I'm going to show you guys of how to integrate this MIT question. So this is from the quarterfinals 2025 and it's the third problem. And you guys should know that this question has to be done within 3 to 5 minutes, I guess. I'm not sure about the time limits you get. But I'm going to give you guys a detailed explanation of how to do this question using the proper substitutions. So let me just write the question 1 over x to the power 8 minus x to the power 6 dot dx. You could write that as the integration of 1 over x to the power 6 into x to the power 2 minus 1 dot dx. I just factorized the denominator. Now what we could do is we could take a substitution of x equals sec u. Then I can write dx over du. The differentiation is going to be sec u into tan u, right? Then I can write dx equals to sec u tan u dot du. Now when I go back to our question, 1 over x to the power 6 I can write as sec u to the power 6 into x squared minus 1. I could write as sec squared u minus 1 dot, instead of dx I'm going to write sec u tan u dot d. I can cancel this off. Now then this will become 5, right? I'll just write it like that for now. And this would be tan squared u, right? You could cancel off with tan u and you'll just end up with 1 tan u, right? So you have 1 over sec u to the power 5 into tan u, right? I hope you all understood this. So if you guys have any doubts, please drop a comment. I'll help you guys out. Okay, now you could write sec u as 1 over cos u, right? So meaning it's 1 over cos u to the power 6 into tan u, you could write as sin u over cos u, right? Now this fraction will give you, oh, hold on a minute. So this has to be cos u to the power 5 because it's sec u to the power 5, right? I by mistake wrote 6. I'm sorry about that. So this is the fraction you get, okay? So now this fraction will end up as cos u to the power 6 over sin u. Because you can see if I multiply these two together, I get cos u to the power 6. That goes to your numerator. And sin u remains at your denominator, right? Okay, now what you can do is let's take another substitution of t equals cos u. So dt over du equals to minus sin u, right? So you could write dt over sin u equals to du with the minus in front. Now, if we go back into your question, we could write cos u to the power 6 over sin u. Instead of du, you can write dt over sin u. I'm going to put the minus in front of the integral. So now you have cos u to the power 6 over sin squared u. Sin squared u, you can write it as 1 minus cos squared u, right? Now let's put in our substitution back in. So t equals cos u. So you could write cos u to the power 6 is t to the power 6 over, and cos squared u is t squared, right? So 1 minus t squared dot dt. If I multiply the numerator and denominator by minus 1, I'll get the integration of t to the power 6 over t squared minus 1 dot dt, right? And by the way guys, I'm really sorry if you guys hear any background noise. It's a bit noisy today, so I apologize. And okay, so now if I we're going to the question. If I divide t to the power 6 by t squared minus 1, I'll have t to the power 4 here, because t to the power 6 divided by t to the power 4, so t to the power 6 divided by t to the power 2 is t to the power 4, right? So then t to the power 4 into t to the power 2 is t to the power 6. T to the power 4 into minus 1 is t to the power 4 minus t to the power 4. T to the power 4 comes down. Since there are no values, you can just write plus 0 over there. T to the power 4 divided by t to the power 2 is t to the power 2. T to the power 2 into t to the power 2 is t to the power 4 minus t to the power 2. So you guys get what I'm doing, right? This is polynomial division. So t squared plus 0, this would be plus 1, t squared minus 1, and your remainder is 1. So you could write t to the power 6 over t squared minus 1 as t to the power 4 plus t to the power 2 plus 1 over t squared minus 1. Now instead of integrating that, we could just integrate this, because it's way easier integrating that, right? So now you should integrate is, now what you should integrate is t to the power 4 plus t to the power 2 plus 1 over t squared minus 1 dot dt. So what's the integration of t to the power 4? That's t to the power 5 over 5 plus t to the power 3 over 3, which is the integration of t squared, plus 1, the integration of 1 is t, plus the integration of 1 over t squared minus 1 dot d. Now how do you integrate that? So 1 minus t squared minus 1, you could write it as 1 over t minus 1 into t plus 1, right? Which you can write it as a over t minus 1 plus b over t plus 1. We are breaking them down into partial fractions. So 1 equals to a into t plus 1 plus b into t minus 1. So when t equals 1, a equals half. When t equals minus 1, b equals minus half, right? Okay, so when you go further, you could write 1 over t squared minus 1 equals to 1 over 2 into t minus 1 minus 1 over 2 into t plus 1. So instead of integrating this, all we have to integrate is this now. So what's the integration of 1 over 2 into t minus 1 minus 1 over 2 into t plus 1 dot dt? Easy, right? You don't even have to do anything. You just write half into ln t minus 1. You can see the differentiation of this will give you that. If you want me to show it, differentiating this, you get 1 over t minus 1. Differentiation of what you have inside the ln function is 1. Differentiation of t minus 1 is 1. And you just multiply it by half. So you can see you get the same exact thing, right? So half ln t minus 1 minus half into ln t plus 1. Okay, now you got the answers, right? Now we have the answers. So our final answer would be t to the power 5 plus t to the power 3 over 3 plus 1. I'm sorry, not 1, it's t, right? Yeah. T plus half ln. Now, instead of writing it like this, we could write it as half ln t minus 1 over t plus 1. Logarithmic rules, as it's minus meaning it's division of the terms you have inside. Half ln t minus 1 over t plus 1. Now let's go back into our substitutions. What did we take? So we had t equals cos u, okay. And we had Where is it? Oh, x equals sec q. So x equals sec q, meaning x equals 1 over cos u, right? So you write cos u equals 1 over x. So t equals 1 over x. Okay, so you go into your answer back again. So instead of t, we are going to write 1 over x. So 1 over. So if you look carefully, when you put 1 over x into t to the power 5, it becomes 1 over 5 into x to the power 5, right? Plus, when you put 1 over x into t to the power 3, it becomes 1 over 3 into x to the power 3. Plus, and t is just 1 over x, okay? Plus half into ln. Now, t is 1 over x minus 1 over 1 over x plus 1 plus c. Now, if you simplify this fraction, it's 1 over x. So you could write 1 minus x over 1 plus x over x. X cancels off. You get 1 minus x over 1 plus x. Again, if you just... Yep, that's your... This is the final fraction you get. Okay, so you could... Instead of writing this whole thing over here, you could just write 1 minus x over x. So 1 plus x. That's what we got, right? Let me just... Yeah. 1 plus x. Yeah. This is your final answer. So that's everything for this question. So if you guys have any doubts, please drop a comment. I'll help you guys out. And this question wasn't that bad, right? You guys can understand definitely. So yeah, anyways, if you guys have any doubts, please drop a comment. And if you guys like my teaching, leave a like and subscribe. Have a great day. Thank you so much.